Hey, all right, second video of this very last lesson. This one is comparing graphs and equations. So when we look at this, you're going to see a really similar thing to the last one where we were comparing an equation to a table. I'm going to be looking for slope and I'm going to be looking for changes in y-intercept. Just those things. That's all I'm going to be focusing on. Just so that way I can look at these various scenarios with a very focused mindset. Now, you can always compare things in different ways, but at the same time, if you can look at them in terms of the same format, it can be really helpful. So in this case, we have an equation here, we have a graph here. If I look at this graph, I can see that I have a y-intercept of 4 versus this one has a y-intercept of 2. And it's a little bit difficult for me to totally see the slope on this particular graph, but it's just because my graphing ability is a little lacking. I'm going to turn this equation into a graph and I'm going to just graph it right on top of there just to see what it looks like and see what we have going on. If I can compare them in the same format, I can look at them with like a focused mindset. So I have y equals 1/2 x plus 2. So that means my y-intercept is at 2. My slope is 1/2, so I'm going to go up 1/2, up 1/2, up 1/2, up 1/2, and so on. I'm going to try to get a few points on there so I can now graph it. Ooh, looking at my graph, I can just see it in my computer screen. Hopefully you can see it. If I look at this, it looks like these dots are almost running parallel to this line that's right here. Interesting. So let's just see if we can connect the dots here. And if we were to connect the dots, that is exactly what's happening. If I look at this black line, I can also do a little bit of checking on the slope. It looks like there is a clear point here. So that means it's going up 1 to the right 2, up 1 to the right 2, and so on. So that means the slope of this black line right here is also 1/2. So the slope is 1/2. The y-intercept here is 1, 2, 3, 4. Y-intercept is 4. So my equation for this black line on top is y equals 1/2 x plus 4. So it doesn't matter. What's kind of nice is we can say that the slopes are the same. They are increasing at the same rate of change, but our y-intercepts are different. This top line is always going to be just a little bit further ahead in terms of like how much it builds than the purple line down below or from the line from the equation. So we can look at those two different aspects in this scenario and we can say the purple line or this line on top, this purple equation, has the same slope but different y-intercept or a higher y-intercept than this equation here that we graphed down below. Same slope, lower y-intercept. Kind of cool. So essentially what we just figured out is we had parallel lines. What constitutes a parallel line? Different y-intercepts, same slope. Kind of cool. All right. We will look more at parallel lines when we get into our systems of equations unit. However, right now with this concept, we can at least compare parallel lines in different formats. Thanks for watching. We have one more video after this that deals with new concepts. And then the very last video will be a word problem that compares all 3 different scenarios at once. Thanks for watching. Bye.